Okay, so first of all, can you all see the screen? Just double check that first. Can you all see the big vectors? Yeah, lovely, thank you. Right, so vectors is something which is covered at secondary school, sometimes not in a great amount of detail, and some of the questions are quite difficult as well when you talk about collinear, but we don't tend to get too much of that on this course. Vectors used to be quite a big part of the old course, which is a bit of a shame, so it's a bit watered down now. Really, this is in mechanics. So let's move forward and have a look. So you tend to find vectors a little bit are basically a journey. They have a magnitude, a size, and a direction. Now all a vector does is tell you how you get from one place to another. That's all it does. A vector just describes a journey. Okay. Now if wherever we start the journey is down to really the question. Okay, but fundamentally in our course we have to the right, which is called the I direction. Now whenever you're writing a vector, you must underline it when you're writing it. When you're using a piece of text, if you're typing it, then you use a bold. Okay, so you'll see it on the worksheets. So we have an I direction and a J direction. Okay, just like the X and Y axis. Now we're not calling them X and Y because X and Y tell you a position, whereas a vector tells you basically how to get somewhere. Okay, so for vector A here, this is 1, 2, 3 this way. So I say the vector describes a journey. So A is it's 3i, and then I need to go up, which is for J. That is an I apparently. Okay, so I'll write it over here. I'll write it in white. I have to keep changing colour. So the way I would write A down then, so I would write A, underline it because I'm handwriting it, is equal to. Now I've got two ways of writing this. I prefer column vectors, so I would write that as 3, 4. But the other way to write it is 3i plus 4j. So you've got two ways of writing it. Sometimes in the exam you're given questions like this, sometimes you're given like this. I personally prefer column vector form, but you need to be able to cope with both. Okay, let's have a go at B then. In fact, if someone wants to type in the chat box for me, what would B be? Can I have it in I and J form, please? Just load up the chat box. Someone wants to chuck in, I would write that down in I's and J's. Got nothing in there yet. Lovely. Okay, so with this one here, and this is why I'm sort of doing this lesson here. So yeah, one thing to be careful of here. Okay, we're going backwards this time. So this is the negative I direction. So that's minus 1i or minus I. Okay, and then because we're going down, oops. I can't really draw straight. 1, 2, 3, 4, 5. It's going to be minus 5j. Okay, it does matter which way you go. So really well done for some of you who did type it in there. Okay, yeah, some of you got it right, some of you got it wrong, which is absolutely fine. When you first learn something, mistakes will happen, and that's absolutely fine. So in column vector form, it's going to be minus 1 because we go minus 1 across. So we go 1 to the left, and then we go 5 down. Now you should have come across this before when you did translations at secondary school, when you like move shapes along. So it becomes minus I minus 5j. Okay, so hopefully I've just stopped some misconceptions there. So if you go backwards, it's a negative. So we'll try again, see if we get an improvement this time. Okay, could you write C for me in I and J form, what we call component form? Ah, lovely, got some answers now. Yeah, and we're getting a bit more of a full house, which is great. Let's have a quick look. Sorry, I have to keep changing colour here. I've been reading some research which says white on a dark colour is much more effective for your guys' concentration. So, yeah, we're going backwards to I, and this time we're going up, which is positive, which is 2J. Quickly change colour again. But yeah, this is the introduction into vectors. So, as we mind, let's chuck a column in. -2, 2, which is -2I plus 2J. Okay, so that's a brief intro into vectors. Okay, and we're always working in I's and J's. Okay. Yeah, lots of you got that. Brilliant. Well done. Okay, so yeah, so make sure you write this down. If you want to give them a quick sketch, you can do as well. That's absolutely fine. And I'm going to tiptoe forwards ever so slightly. Okay, so these forms here are what we'll call component form. Because if you have a look at it, a component means part of, and the vector is in two parts. Okay, moving forwards. Now I've got the same problem this time, but this time I'm not going to use component form. I'm going to use something called magnitude and direction form. Okay, so first thing I'm going to do is I'm going to write down over here, I'm going to talk about magnitude. Does anybody know what the word magnitude means? Chuck it in the chat box. So I have to keep scrolling on my phone. Everyone know what the word magnitude means? Length, scale, yeah, keep going. Any more words? You're sort of right, Eden. Any more words? Size? Yeah, it is. It's basically the size, how big something is. So, when we talk about the magnitude of a vector, we basically mean how long is A. So basically on A here, how long is it? Now, what's nice about vectors, well, if you do a maths degree, you'll come across, not all the time do we use a square grid, we could use other things, but just looking here, this was 3I, and this is 24J. And basically want how long it is. Now, it is a Pythagoras problem, but the way we write it down is ever so slightly different. So, basically, the way we write magnitude down, we give it, now, these lines are called modulus signs. So basically, that there means magnitude. It's two sort of long lines, like capitalize if you wish, A, underlined to show that this is the magnitude of that vector. Maisie's Wi-Fi keeps dropping it. Well, tell Maisie, Abby, I'm recording it anyway, alright. If I don't run out of disk space. I haven't plugged in with the hard drive. Okay, so the way we find the magnitude is basically to do Pythagoras on it. So we're just going to square root 3 squared. Lost my pen there. Plus 4 squared. So basically, if you were asked to find out how long that is, you just do Pythagoras. Pretty much like doing that distances work last week on the straight line stuff. And there you go. So the magnitude, the size of that is 5. Now the magnitudes will always be positive, because if we're talking about a size of something, we're gonna. This isn't a this is just a scalar in this case. Okay. With that in mind, guys, can I ask you to find what would the modulus of B be? Modulus or magnitude, and what would the magnitude of C be? Because we're going to need these later. Right, okay, we're back recording. So, for B then, I'll quickly do it just for the video. So it's the square root of, and the length of this is 1, 2, 3, 4, 5. So it's 5 squared. Now notice I'm putting the 5 in brackets. The only reason I'm doing that is because if we're dealing with negatives, then negative needs to go inside the bracket and the calculator can cope with it. We don't want, I know some people's work in the past has gone a bit wrong because of the negative situation. So root 26 for B, and for C we've got 2 squared plus 2 squared, which is root 8, and then I would be tempted to cancel that down to root 2. Root 4 times root 2. Cancel that down. So that's how you work. That's how you basically get the magnitude. It's just the size of the vector, and you can just do Pythagoras on it. Now what you might also be asked to do is to find the direction. Now if you're asked to find direction, it always will be relative to another point. So let me just show you what I mean. So you might be asked to find the, and I'm just going to clear my annotations just for now. So you might be asked to, in colour, so it's still white. You might be asked to basically find the angle A makes with the I direction. Notice again the I is getting underlined there. Okay, so you might be asked something like that. So find the angle A makes the I direction. So what I'm going to do is I'm going to sketch it and then put in the I direction. So there it is. There's A. Okay, now we know we can fill in whatever we like now because I can find out, we know how long A is. So I'm not going to use that because if I make a mistake it's going to be ruined. So I'm just going to draw in the I direction, which is there. And there's the J direction. So we know for this particular one, it's 3 across and it's 4 up. Okay, and it wants the angle it makes with the I direction. Now it should say something like the positive I direction. So basically I want the angle, I want that one there, which I'm going to call theta. I'm using lots of thetas. Okay. So all I'm going to do is approach this by using bog standard trigonometry. So the angle, so I do SOHCAHTOA on it. So this is the opposite, this is the adjacent, this is a hypotenuse. I mean, if you've got the hypotenuse, you can use it, but I'm going to use the opposite and adjacent. So it's going to be tan theta, and it's O over A, so that's 4 over 3. And so theta is going to be the inverse tan, or tan to the -1. I know we haven't done much trig yet, but say give us a shout in the chat box if you're unsure about how to do trig. So grab my calculator because I can't do that in my head. I think it's probably around 75 degrees or something like that. No, it's 53 miles away. So I'm going to just take that to, I'll take it to 1 dp, so 53.1 degrees. So what you can do then is you could write it what we call magnitude direction form. So the other way we could write A is to write that as, so if we're asked for it in magnitude direction form, it'll always tell you which angle you want. So magnitude direction form would be 5 magnitude and 53.1. Okay, and I'll just jot an arrow on that. My advice to be honest with you, would be to sketch it. So you might be given the magnitude direction form and asked to recover what the 3 and the 4 are, and all it takes is a little sketch. So okay, right angle triangle. Okay, it's told us that the magnitude is 5, so that's the length of it, and it tells us it's 53.1, and then you could basically perform trig on it again to get these two unknowns. Okay. Just make sure I've got. Oh, just put that calculator. Are you in radians by any chance, Eden? I think you're in radians. So if you go to press Shift menu, you'll see something where it says angle, and you change that to deg, you'll be on rad at the minute. So there's different ways of measuring angles. Yeah, got it. Okay. So another thing you might be asked as well, you might be asked basically what angle it makes with the J direction, which in this case you'd be working out that one there. But I'll look at that in a second with you. So what I'd like you guys to do, just for now, is to, on each of these questions, could you work out what each angle makes with the positive I direction? And we'll have a look at that together. So just for A and B, I'll pause the recording. Could you work out what the angle each one makes with the positive I direction? Just give you a few minutes, thank you. Okay, so if you look at what I've done so far, you'll see, because it wanted the angle between, now it does matter in which direction a vector goes, so if you've been caught out here, don't worry about it. If there's the I direction there on B, it wants this angle here. It could ask for the other angle, but it'll tell you whether it wants clockwise or anti-clockwise, but I'm not going to get too stressed about that right now. And now you'll notice that this one here is made up of this right angle plus this that tiny little angle at the top. So what I've done is I've worked out this little angle here, theta, and I've got that as 11.3 degrees. And the only thing I need to do now, in terms of writing down the angle, is just to add 90 on. So the angle, and this is the clockwise angle, is going to be 101.3. Okay, so if you got that one wrong, that's fine, because I didn't mention too much about it. So when we're looking at C, then I'll do C here. I'll do it in a box. You can check. So for C, let's give it a quick sketch. So there it is. And this is minus 2i and 2j. And there's the positive I direction. There it is. So what I want is this angle here, which I'm going to call alpha. Okay, so if you work out this angle here, which I'll call theta, so if that writing's a bit small, if you're using the phone, that's actually going to be quite tiny. So if I work out that angle there, which is theta, I can do 180 minus and work out alpha. So let me draw that bigger triangle then. So let's work out theta. So that's minus 2. In fact, let's just have that as 2 and 2. We're only drawing a triangle, aren't we? So it's going to be, again, same thing. I'm going to use tan. And the only reason I'm using tan is because I know that 2 and 2 is correct. I could use the hypotenuse. I could use that as 2 root 2. But if I make a mistake in that part, then I'm going to follow through the error. So I'm better off using the opposite and adjacent. So theta is going to be tan to the minus 1 of 2 over 2, which I reckon is 45 degrees. And, I mean, you can just look at that one and go, oh yeah, I can see it's 45 degrees. And therefore, alpha is going to be 180 minus my 45 degrees. So alpha is 135 degrees. And I'll draw these on the diagram so you can see. So on this B, it was that angle. And on C here, it does seem fussy. But if you get this nailed, when we come onto where we're using this in harder bits of maths, the angles all sort of fall out. It all comes together really nicely. So that's 135. You think of it like hands of a clock. If that's where the pin is, and that's the way, obviously don't worry about anti-clockwise and clockwise. But that's where you put the pin in, so that's the angle that you measure. Same with this one. So basically the angle it makes with the 3 o'clock, head to check then. Okay, same with this one. So there's the I direction, which is basically 3 o'clock. So you'd be working out that angle there. It could ask for the other angle. It could ask for the one the other way around. Obviously, you just do 360 minus. Is that okay, guys? That's probably enough to get you guys started on the worksheet. But I want to cover all this off as much as I can. So that's magnitude and direction there. Any questions about that? Any problems? Any struggles? It does require a bit of SOHCAHTOA. But if you've ever got any burning problems and you don't want to speak in front of people, I'll stay on the Google Meet at the end, and we'll have a look together. All right? Because I know I've had some questions, didn't you, about unit vectors. Okay, but we'll cross it when we get to it. Right, next slide. So I've just put this. This is a bit of a random question, but I've put this in. I was looking through my old PowerPoints from a few years ago, so I've just chucked this in. This one does seem a bit random, but this is something that you should have covered at secondary school. And I will show you how to do this. It's normally the first lesson. So you normally get taught vectors, and then your sort of first lesson when you're doing the higher paper is this sort of stuff. So the idea is, and what you should be taught at school, if this is point A here, and this is point B. Now this is just a bog standard XY grid. And the origin is there, which we give an O, which is 0, 0. And then what we tend to do, and this is sort of a normal example that I always dive to, you'll see me doing this in the second year as well. Same diagram appears in my second year further math group as well. Okay, so I'm going to call this one vector A, underline. Call this one vector B. Now if you want to work out the vector AB, A to B, well, how do you get there? So we're starting at A and we're getting to B. Well, we need to go backwards along A to get to the origin, and then we go up along B. So in that case, it's just B minus A. Now that is a standard result that we do use in vectors. Now hopefully you've come across that before. I've certainly come across that diagram. If you haven't, jot it down now. Has anybody not come across that before? Right, okay, so let's have a look how it works in practice then with P and Q here. So if we look here, now these are all relative to the origin. So O to P, so if I'm going the origin to P, how would we get there? We'll go -1 across and 3 up. How would we get from O to Q? Well, that's 7 across and 2 down. Okay, and what we can do then is enter these, let's write these out a little bit neater. So we might call this one vector P is equal to minus 1, 3. Now you'll see, this looks really, really fussy, but there is a point to it. In terms of when we write, I'm using lowercase for some unknown reason. We don't normally tend to. Vectors normally get lowercase, and you'll find coordinates tend to get uppercase. Okay, so turn them into vectors. Okay, and what I'd like to work out then is Q to P. So if I look down here, A, B is B minus A. So A is the first letter, Q is the first letter. So this is going to be, and just match them up here, it's going to be P minus Q. Okay, so all I'm going to do now is grab P minus 1, 3, and take away 7 minus 2. Now I haven't got an XY grid, but I will try and draw it in a second so you can see. So minus 8 and 5. Okay, now this is really, really abstract, but let me show you what it looks like on a grid. This will be my best effort of drawing it. So there's the origin. We've got P as minus 1, 3, so minus, oh, I'm going to struggle to get 7 on, never mind. Minus 1, 3, so there is P, and Q is 7 and minus 2, so 7 minus 2. And basically I want, how do you get from Q to P? And if you have a look, I'd go 8 across, bounce it across, you go all the way across 8, and then you go up 5. Now it's great if you can draw it and see it, but there are more complicated problems, which is why I've done it abstractly. So that's how the two pictures match up. Does that make sense? And that leans on something you guys should have done at secondary school. If you didn't, don't worry about it. If anyone wants to go back over anything, I will. Just chuck it in the chat. Does that make sense? That's definitely 2 people. Thank you, Jacob. Cheers, Anthony. I think the rest have fallen asleep. Ah, there we go, some more. But you should have had quite a lot of experience of doing that at secondary. I think vectors, if you had a really good math teacher, you really enjoyed your math lessons, that's something that's quite nice to pick up and learn and get on with. Lovely. Right, I'm going to move forward. So you won't get any questions like this. I don't think on the worksheet, but I thought it's worth covering off anyway, and then I'll pick it up at another point in time. All right. Right, moving forwards ever slightly. I'm going to have to change the deadline on the worksheet, I think, which is fine. So, next thing I want to do is I want to look at unit vectors, because I've had an email about unit vectors. So, first of all, let's just define a unit vector. So, a unit vector has a magnitude of 1. Okay, that is literally the definition. A unit vector has a magnitude of 1. And that is it. Okay, and the way you write a unit vector is A, and you give it a little hat, like that. You'll see me do a bit more of that in a minute. Okay, so unit vector has to have a magnitude of 1. Okay, that's all we're going to do. So we're going to check whether A here is a unit vector. So let's first of all find the magnitude of it. So grabbing my calculator. I'm not going to get caught out by squaring the minus 1 wrong. Add 2 squared. And so that's going to be the square root of 5 as root 5 is not equal 1. It's not a unit vector. And feel free to add your own punctuation. Okay, does that make sense? I say unit vectors are quite nice to do. There are some more complicated problems, but as a start off, they are quite nice to do. So unit vector has a magnitude of 1. work out the magnitude and work from there. So I've written it on there, look. What about that one then? Could you calculate then for me? Could you work out whether B there is a unit vector? And don't forget to underline it if you write it into your notes. Okay, so find out whether B is a unit vector for me, please. And then you can just type in the chat box yes or no. Just put yes. Thank you, Taylor. And so, I mean, if you use the brackets, you use the formulas, your calculator do all the job for you. It's quite nice to do. Yeah. Spot on. I'll begin to write this out then. So, magnitude of B, where my pen appears, is the square root of 1 over root 3 squared plus square root of 2 over 3 squared. By the way, if my writing is too small, give me a shout and I will make it larger. So we did yesterday. So, without using a calculator, let's have a look. So 1 squared, root 3 squared. Now if you square a square root, it sort of disappears. And then common denominator, look, you've got two fractions, common denominator. So you can do it without a calculator. So it's 3 over 3, which is 1. So B is a unit vector. Okay, which lots of you got in the chat, so really, really well done. Okay, so it's nice to do unit vectors, but the questions do ramp up in difficulty, as you'll see in a second. Okay, now, the other thing I need to get you guys to do is to write down the unit vector parallel to this. Okay, now, when you're working with the vectors, and I'll just do an example over here, then I'll delete it. So if you've got a vector, say A, which is that, what you can do with vectors is sort of work with them a little bit. So 2A, it goes in the same direction, but it's twice as long. And a half A is basically half as long. Okay? You can have them pointing in the opposite direction as well, in which case that's minus A, because it has a direction and a length. Okay? And then if you want to, you can come up with all sorts of configurations. So if you wanted, I don't know, root 5 lot of A, so it's going to point in that direction, and whatever root 5 is, 2 point something, it's a little bit longer than A should be. Something like that. So that's going to look at. So what I want then is to find the unit vector which is parallel to this. So it's going to be some sort of multiple of this. Now it is a dead easy little task to do. So the first thing I'm going to do, okay, is work out what the magnitude of A is. Okay, so work out the magnitude of that. So it's going to be 5 squared minus 5. 5 squared. I might put the minus on it. Plus minus 7 squared. Grab my calculator. So that's going to be 25. Add 49, which is 74. Just check that doesn't cancel down. I don't believe it does. Okay, so what we're saying is, let's just think about this logically just for a second. I'm just going to clear this over on the right hand side here, because this is quite a difficult thought process to go through. But I'll try and explain it as best I can. Pen. Right, so what we've got here is A, which is 5 minus 7. So A is 5 across, 7 down. So A is something like this. It's absolutely massive. Something like that. In fact, I should put the arrow there, doesn't matter. I drop my pen. Okay, so this is A here. It's absolutely massive. But what I want is a unit vector which is smaller, but points in the same direction. And this unit vector here, which is A hat, that has to have a magnitude of 1. Now, if you think about it, if this magnitude came out as 2, we'd just half it, wouldn't we? We'd just make it half as long. So let me show you what you do. It's quite easy to do. All you do to get a hat is do 1 over the magnitude, 1 over root 74, because what that's going to do is going to shrink the length of it down to 1. Because this has got a length of 74, root 74, when we divide it by root 74, it's going to shrink to 1. And then all you do, in fact I've lost my little squiggly line there, is just write the vector next to it. And I'll prove it to you in a second. So, and that's literally it, guys. That's how you get a unit vector. So it's like 1 over the magnitude. In fact, more formally, let me just scrub that out because that's not my best bit of writing that. In terms of more, if you want a formal way of writing it, a hat is 1 over the magnitude of a, and we don't worry about, I'm going to use a dot there, dot a, but basically you get the magnitude, flip it over, what we call reciprocal it, and then just write the vector next to it. So basically what I'm going to do now is I'm going to check this is actually a unit vector. So let's work out over here what the magnitude of a hat is. So what you can do with a vector is take it inside. So if I want to take this inside, my new vector is going to be 5 lots of root 74. Look at the way I've taken it inside. And minus 7 root 74. So what I'm going to do now is grab my calculator. I know it's going to work out as 1. But I'll do it anyway. So this is me just checking my answer here. You don't ever really get time in a proper exam, but it's worth checking whilst you're working on it. Grab my calculator, so it's going to be shift, and I've gone for 5 over shift ants squared plus minus 7 over shift ants. Make sure I square the bracket, and there we go, it comes out as 1. And there we go. So my answer is there. That's a hat. Is that okay? Any questions about that? So you find the magnitude, write it under 1, and then you literally write the vector next to it. And if you've got time, then you can check it. Is that alright, guys? I'm going to give you guys one to do, and then we'll check it together. Alright. It looks way more complicated than it is. So I'll give you guys just a couple of minutes just to write that down. And hopefully I've done it a bit of justice. But it's just simply a case of just dividing by the magnitude. It'll shrink it down to 1. Okay, right. I'm just going to erase my ink here, because I think I've got one for you guys to do. Okay, could you calculate the unit vector parallel to minus 6i minus 2j? And I think I've only got one more example after this, but hopefully you're finding this more, possibly more useful. I needed to do some direct teaching for this because the videos are quite bitty. If you try to do this exercise already, you'll see the videos are quite bitty, whereas I just want to get straight to the point on this. But have a go, please. I'll write the answers up in just a minute. Guys, as always, guys, I'm just going to jot up the answer slowly. Okay, if you want to check your answers against mine, I say I would make the calculator do all that arithmetic and let it simplify it to 2 root 10 for you. So hopefully you've got the same answer as me. Now the only thing I'm going to do now is notice I've written it in both. These are both component forms. This one's using the sort of vector format of the big brackets. This is using INJs. The only thing you might come across is like expanding this. Just thinking about all the different things I've seen on these questions. You might see it written like this. You might see that written as minus 6 over 2 root 10. I know that can be cancelled down. I minus 2 over 2 root 10. There's a 10, I promise. J. So you might just see that expanded. So just watch out. All those three are exactly the same, but the examiner might ask for either one of those three. All right. Is that all right, guys? I think I've only got one more example, then we'll move forwards. But hopefully finding this useful. And if you've never done vectors before, hopefully it's providing a bit of use for you. So I'm right to move forwards. Thank you, Jacob. Jacob, you're being the leader at the minute. Nobody else is really responding. But yes, let me know. Thank you. Cheers, guys. Right. The only time this gets difficult, and all of a sudden this appears from nowhere with this unit vector stuff, and I'll show how it works now. Thank you, Anthony. You've gone for 2 letters now. You may as well just put 1 in the future. There's no Rick rolling today. Right. Last one I've got for you is something a little bit like this. Okay. So, all of a sudden this appears from nowhere. So find 2 values of k so that c is a unit vector. Okay, so we've got some sort of values of k that'll make this a unit vector. So the first thing I'm going to do is I'm going to turn this into column vector form because I prefer it. I've got literally no other reason why. And that's a minus 9k. So k here is some sort of value, and we want to make this into a unit vector. So what I normally tend to do in these questions is just look at, it wants a unit vector, okay, so what's the definition of a unit vector? As a length of 1, right, okay. So the modulus of c, the magnitude of of c has to be 1. That is my starting point. Okay? And then you've got to ask yourself the question is, how do you get the magnitude? Well, you just square root, even if it's got a k in it, I still do the same thing. So it's going to be the square root of 12k squared plus minus 9k squared is equal to 1. And all I've done there is I've swapped that c there for this equation underneath, because that's how you get the magnitude. If it's got some k's in, so what? Everybody in this class is good at algebra, so then from there, now you could square both sides. I'm not going to. We'll have a look in a second. Why? Yeah, maybe I should bet. Well, we'll have a look. So we end up with 144 k squared plus 81 k squared equals 1. In fact, I'm going to square both sides now. So 144 and 81, I think is 225, isn't it? Yeah, 225. So what I'm going to do is I'm going to square both sides now, get rid of that square root. So I'm going to with 225 k squared is equal to 1, and that's me just squaring both sides there, and I've done a bit of adding as well. I'm going to divide through by 225, so k squared equals 1 over 225, and then the last thing to do is then square root. Now we must take the plus and minus square root, because what will happen then if k is negative, it's just going to be the same vector but pointing in the opposite direction. So 225 I think is a square number. I think it's 15 squared, isn't it? Just check my calculator. Yes, it is. So k is equal to plus or minus 1 over 15, and that's me just square rooting that. Okay, and that is as sort of difficult as these questions get on this worksheet. Okay, so look at what I've done. I've just stuck to what I know. It says it wants to be a unit vector, which is what. So I've written the definition down. I've swapped c for the what the actual vector is, and then I've worked through. I maybe should have squared first. Doesn't matter. But and also as well, that's for 2 values of k. So I know in that case it's going to be a square root of the plus minus on. And there you go. And you can. And what we can do then is we can actually just rewrite, if we want to, don't have to, we can just write C slightly differently. So it's going to be, there are two values for C, but it's going to be plus minus 12 over 15 plus minus, in fact it's going to be minus plus, because that's a minus. I'm not going to get too worried about that. 9 over 15. Okay, but you don't need to do that. Just get the values of k. And if you've never seen a minus plus before, it's we'll meet it in the second year. It's not particularly difficult to cope with. It just does it the opposite way. Right, I think I've got one for I've got one for you guys to have a go at. So have a go at that, and then that's our video done for this lesson. So as always, I'm just going to jot it up in silence so you can compare. Okay, so there it is jotted up for you, if you want it. Okay, so that's 1 over root 13. Spot on, Josh. So yeah, I think that's as difficult as this worksheet gets. So I know the time is 17 minutes past 2, but hopefully you found that more useful, me going through each individual skill and then sort of battling your way through, because I think the worksheet is it's a bit all over the place. And Abby, does that clear up any misconceptions you had or anything? I'm just going to stop recording now.